Hello, guys. Today I'm going to talk about different rocks that we have in the nature. And then I'm going to talk about oil petrology. And finally, I'm going to elaborate on geophysical methods and how they contribute to petroleum exploration. In general, rocks can be divided into three categories: igneous rocks, sedimentary rocks, and metamorphic rocks. Igneous rocks are those rocks that are formed through cooling and solidification of magma and lava. And magma and lava are those molten materials that come out of volcanoes. Depending on the cooling process, igneous, igneous rocks can be divided into two subcategories. The first category is intrusive or plutonic rocks that in which their cooling process is very slow. So usually these rocks are formed within the earth, and because the cooling process is slow, crystals are developed. In other words, if we look at the rock sample, then we may be able to see those crystals. Examples are dunite, diorite, gabbro, and granites. If the cooling process is so fast, we're going to have extrusive or volcanic igneous rocks. In other words, if the cooling process happens close to the surface or on the surface, then we're going to have extrusive rocks and there is no crystals. Examples: basalt, andesite, rhyolite, and obsidian. Another categories of rocks are sedimentary that are formed through compaction and cementation of sediments. And sediments are those fragments of rocks that are generated due to weathering. So one of the most important terminologies that we use in oil and gas exploration is sedimentary basin. And a sedimentary basin is a place in which there is a lot of sediments. So how we categorize sediments is very interesting. We categorize them with respect to their size. For example, the largest size is boulder when we have cobble, pebble, sand, silt, and clay. And indeed, clay is the finest sediment that we see in the nature. Again, similar to igneous rocks, sedimentary rocks are also divided into two subcategories: clastic sedimentary rocks that are formed through compaction and cementation of sediments. And examples are conglomerate, breccia, sandstone, and shale. And if you look at here, you see that, for example, conglomerate is mostly composed of larger grains compared to shale that is composed of clay minerals. Then we have non-classic sedimentary rocks that are formed as a result of, for example, chemical reactions or evaporation. Examples: limestone, rock salt, gypsum, and chert. The third category of rocks is metamorphic rocks. So whenever a rock is exposed to high temperature or pressure, the minerals are deformed and new minerals are constructed, and that's the reason we call the rock metamorphic. Metamorphic again can be divided into two categories: contact metamorphic rocks that are formed when a rock is exposed to high temperature. For example, assume that we have a magma and all the rocks in the vicinity of the magma go through contact metamorphism. Example: quartzite and marble. And then we have regional metamorphic rocks that are formed due to the high pressure, for example, as a result of tectonic activity. Examples: slate, phyllite, schist, and gneiss. So when we talk about oil petrology, there are several important uh, concepts that we have to learn. One of them is porosity, and the porosity is the measure of volume of pores over the total volume of the rock. For example, when we say the porosity is 10%, it means that like 10% of the rock is pore and the rest are matrix. And why this concept is important? Because oil and gas are stored within those tiny pores, and the higher volume of the pore we have, it means that we're going to have more oil and gas stored within the rock. Okay, for example, consider a rock that has a porosity of like 2% with another rock that has the porosity of 30%. So the rock with the porosity of 30% has more ability to store more oil and gas. In addition, another important terminology is permeability. That is the ability of the rock to pass a fluid. Again, why this concept is critical? Because we are not able to produce oil and gas from a rock unless it is permeable. And the higher permeability that we have, it means a better production and easier production. Now just let's go how oil and gas are formed. It's a very long process. Million years ago, small marine animals such as zooplankton died, million years ago, and their body fell down over the seabed, and their bodies were covered with a layer of mud. So what we have a layer of mud that has a lot of organic material. So what happens if you look at this figure, that layer of mud also is covered by subsequent sediments, and over the course of the time, we're going to have a layer of rock that has a lot of organic materials, and those organic materials are exposed to geothermal pressure from the bottom and the weight of the sediments from the above. So as a result of high pressure and temperature, these organic materials are converted to oil and gas over the course of million years. So that's the major thing. Oil and gas indeed are formed in sedimentary environment. This is the origin of oil and gas. And that's the reason when we want to find oil and gas, the best type of rock that we have to go is the sedimentary rocks. And within the sedimentary rock, first of all, we have to identify some sedimentary basins in which there are a lot of sediments. And within the sedimentary basin, we have to identify or we have to make sure that several geological factors are available. The first thing is the source rock. So whenever we look at any geological basin, you have to make sure that, okay, there is a source rock. And the source rock, as I said, is a rock layer that has a lot of organic material. And those organic materials are exposed to enough temperature and pressure for a long period of time, so they are converted to oil and gas. And usually shale formation with rich organic material are called a source rock for us. Then we have reservoir rock. Reservoir rock is a porous rock that has the ability to store oil and gas that are produced by the source rock. The seal is an impermeable layer above the reservoir rock, that somehow seals the reservoir and prevents migration or migration of the oil and gas from the reservoir rock to the surface. And when we talk about trap, trap mostly refers to the shape of the seal or the structure that supports accumulation of oil and gas. So here I can explain what I mentioned before. So usually we have a shale layer with a lot of organic materials, and then assume that this shale layer is exposed to enough temperature and pressure, and so organic materials become oil and gas. Indeed, inherently shales are not permeable, but it is possible that due to, for example, tectonic activity, they are fractured, and as a result, oil and gas can escape from the shale layer through those fractures. And once the oil and gas escape from the shale layer, they move upward to the surface or they migrate. So if there is nothing to prevent their migration, they move upward to the surface until getting to the surface. However, it is possible that we have some geological formations that are impermeable. For example, assume that we have a shale formation close to the surface that is impermeable. And what happens here, those oil and gas are accumulated beneath that shale formation, or we call it cap rock. So beneath the cap rock, we have a porous rock in which oil and gas are accumulated. And then above it, we have cap rock that seals that reservoir for us. And as I mentioned, when we talk about trap means the structure. So any structure that wants to any structure has to have some concave shape in order to support accumulation of oil and gas. For example, the concave shape may be an anticline, fault, reef, and etc. Okay, guys. So geology is direct observation of subsurface, and it has some advantage and disadvantage. So the advantage is that because it is direct, we are able to have a lot of information with high accuracy and reliability. But disadvantage is that it is very costly. Okay, so just let me explain it. So assume that here we have an oil reservoir, and what we want to do, we want to have an image of this reservoir for better production. You may say that why not we drill several wells along the reservoir and then by analyzing the core samples from the wells, we identify the geology, and then by interpolating between the wells, we are able to obtain, for example, a 3D or 2D image of subsurface with a lot of geological details. This method is possible, theoretically, but it's not practical because drilling is very costly. Okay. And sometimes we are not allowed to drill a well. Okay. So assume that in some area, this is a private property and the owner doesn't allow us for drilling. That's the reason why we should geophysical methods, as indeed geophysics is indirect observation of subsurface, and we use physical laws in order to explore subsurface. Just let me give you an example. All of us are familiar with the Newton's laws of Newton's law of universal gravitation. For example, if we have two masses m1 and m2, using this equation, we are able to estimate the gravity force. In geophysics, we have some devices that is called gravity meter that can measure the gravity field with high precision. Here is an example how by looking at gravity data, we are able to have some idea about subsurface. So for example, assume that in this figure on the left, you have a dense body, okay, with the density of rho 2, and rho 2 is greater than rho 1, that is the density of the surrounding material. So if we measure the gravity field over the surface, once we get closer to this dense body, we're going to notice that the gravity field increases. And we're going to see such a shape in our gravity data, such a curve. So by looking at the gravity curve, we are able to say, okay, there should be some dense body below the surface. Here is another example. For example, assume that we have a fault here in the figure on the right side. And just let me highlight it for you. Okay. So here, as you see here, we have a fault, and the material on the right side of the fault has higher density compared to the material on the left side. So once we measure the gravity field, we see an increase in the gravity field due to this faulting system. This is how we are able to have some idea about the presence of a fault below the surface using gravity data. This figure shows that, for example, how geophysicists use a gravity meter to measure the gravity. Another method that we may use is magnetometry, that is based on measuring the magnetic field of the Earth. Different geological layers may have some effects on the magnetic field of the Earth, and that's the reason by monitoring or by measuring the magnetic field, we are able to have some idea about subsurface layers. But the most popular methods that we use in oil and gas exploration is seismic. And in this seismic, uh, in seismic methods, what we do, we image subsurface by seismic waves, that is a form of acoustic waves. So usually we have a source on the surface that produce some vibrations or release some energy into the earth. The source can be vibroseismic or dynamite. And then this seismic energy travels down through the earth, inside the earth, in the form of seismic waves. So once the seismic waves impedes different geological boundaries, a fraction of their energy is bounced back or reflected back to the surface. And if we have some sensors on the surface, the sensors are called geophone or hydrophone. That depends on if we are in land or marine environment. We can record seismic waves. And by analyzing the seismic waves, we are able to obtain a detailed image of subsurface. Indeed, in the nature, bats use the same almost procedure. So bats are blind and they can't see their environment. But what they do, they produce high frequency waves that are called ultrasound. And the ultrasound hit different objects and are reflected back to the bat. And this is how bats are able to locate their targets. The similar concept is used in medicine, for example, in sonography. And in sonography, as you see here, we have a device that is composed of both uh, source and receiver. The source produces ultrasound wave, and this is how we are able to see some tissues in our bodies. What you see here is an image of seismic data. And you may say that, okay, you don't see any oil and gas by looking at this image. The reason because you're not used to it, but once you learn seismic and you're going to see that the interpretation may not be that difficult. And then it is very easy, once you learn it, to identify different geological structures and features to the seismic image. The seismic imaging can be 2D, 3D, it can be land or it can be marine. We call it offshore and onshore. So offshore is used for marine seismic data and onshore for land seismic data. And to do seismic imaging, we are able to obtain a detailed image of subsurface. For example, what you see here is an interpreted seismic image of a fault. You see a fault plane here, and this is the continuation of the fault that has been interrupted within this fault plane. Or what you see here, you see an anticline that has been imaged by seismic imaging. And again, what you see here, the seismic imaging can provide us with detailed image of subsurface. Okay, just if I want to summarize my lecture is that oil and gas are usually found in sedimentary rocks where there are a lot of, and when we talk about sedimentary rocks, we have to find sedimentary basins. And within the basins, we are looking for some important geological factors. For example, the presence of source rock, reservoir rock, cap rock, seal. In addition, we have to make sure about timing, migration, and maturity of those organic materials. And then, so this is the part that we refer to geology. But geology is not enough. We need more information. That's the reason we conduct also geophysical studies to obtain more information about subsurface. In particular, we want to identify different geological structures, possible trapping, possible traps that can support accumulation of oil and gas. And then by putting geophysical data and geological data together, we are able to obtain detailed information about subsurface and the possibility whether or not there are some oil and gas reservoirs within a sedimentary basin. So this graph, shows what I mentioned before. So for example, we may use seismic, gravity, magnetometry, but mostly we use seismic for oil and gas. Once we put the data together, geological and geophysical data, we have to drill level in order to further assess the subsurface formations. And one of the things that we do here is well logging, in which we send sensors down to the borehole and measure different rock properties. Okay, guys, I hope that you have enjoyed the lecture today. So I wanted to give you some idea about different rocks that we have and how we can have better information about subsurface if we combine the geological studies with geophysics. I teach a course in Michigan Tech. It's called Reflection Seismology, in which I teach in detail how we use seismic methods for oil and gas exploration. And I agree that, one session is not enough to understand the seismic, but something that you should learn from this lecture is that, oil and gas exploration is very complex process. We have to rely on different types of data to have a solid conclusion about the presence of oil and gas in a sedimentary basin. So one of them is geology, one of them is geophysics, and one type of the data is the logging that is indeed the theme of this course. Thank you.